Welcome to the 11th part of thermal properties of matter, and in this part you will learn about blackbody radiations and thermal conductance. Here is the example 11.6 of your NCERT, and you have to calculate the temperature of steel copper junction in the steady state of the system shown in the diagram. Here the length of the rod is 15 centimeter and of copper rod is 10 centimeter and the temperature of the furnace is 300 degrees Celsius and the other end temperature is 0 degrees Celsius. The area of cross section of steel rod is twice that of the copper rod and the thermal conductivities of steel and copper are given to you. As the insulating material around the rods reduces heat loss from the sides of the rod, therefore heat flows only along the length of the rods. Consider any cross section, and in the steady state heat flowing into the element must be equals to heat flowing out it. Otherwise there will be a heat loss. Thus, in the steady state rate of heat flowing across a cross section of the rod is same at every point along the length of the combined steel copper rod. And T be the temperature of the steel copper junction in the steady state, then by applying the steady state condition and by putting all the values given to you, you can find out the temperature, and that will be the 44.4 degree Celsius. Thermal conductance. It is a reciprocal of thermal resistance. So mathematically denoted by capital G, it will be equals to 1 by R. Or you can say H divided by delta T or K into A upon X. Thermal conductance for series connection of rods. There are two rods of thermal resistance R1 and R2 and they are connected in the series combination. When the steady state is reached, there is no absorption of heat in any part of the rod, you know. So any heat that goes through the first rod also goes through the second rod, and due to this same heat current passes through the two rods, and such a connection is known as series connection. Let T be the temperature of the junction of the two rods. Now heat current through first rod is T1 minus T divided by R1. And through the second rod, it will be T minus T2 divided by R2. By solving these two equations, you can find out that H will be the T1 minus T2 upon R1 plus R2. Thus, we can say that when the rods are joined in series, then the equivalent thermal resistance will be given by simply the addition of the individual thermal resistances. Means the net R will be equals to R1 plus R2 plus R3 and so on. For the parallel connection of rods, consider two rods and they are joined at their ends. From the figure, you can see that left end of both the rods are kept at the same temperature T1 and the other are kept at temperature T2. So there is same temperature difference maintained at the ends of each rod. And such type of combination is the parallel combination of the rods. The heat current going through the first rod is T1 minus T2 divided by R1 and through the second one will be the T1 minus T2 divided by R2. because the temperature difference is same at the each end of the rod. The total heat current will be H1 plus H2, and by putting the values and on solving it, you can see that the value of equivalent resistance will come out to be 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. Black body radiation. A black body is one which neither reflects nor transmits but absorbs whole of the heat radiation incident on it. And therefore the absorptive power of a perfect black body is 1. When a black body is heated to a high temperature, it emits radiations of all possible wavelengths within a certain wavelength range. And these are called black body radiations. A surface coated with lab black or platinum black absorbs 95 to 97% of the incident radiation. But on heating, it doesn't emit full radiation spectrum. So it acts as a black body only for absorption of heat radiation. It is also observed that if hollow cavity is heated, the radiation coming out from its inner surface through a small opening is a full radiation spectrum and is known as cavity radiation. Hence, the small opening of a heated hollow cavity acts as a perfectly black body for both absorption and emission of heat radiations. Here is the diagram showing the A part represents the black body absorber. You can see that inside this lamp black coating is there. Incident radiation enters and it is reflected many times within the body itself. And the B part represents the black body as a emitter through which the heat radiations are coming out.